What is a logarithm?
I don't know.
We don't know yet. We're going to start off with a formal definition of it. I'm going to ask you to write it down. We're going to return to it later in class and see if it starts to make a lot of sense. A logarithm can be defined as the exponent by which you need to raise one number to get another number. And it looks a little weird. Let's just take a very, very simple situation here. I have 3 raised to some power gets me 9. What does that x have to be? What number does x have to be there? 2. Thank you, Dan. X has to be 2. Now, how would I write this in logarithmic form? Essentially what this looks like is this. I'm going to ask the same question that I just asked Jacob. But I'm going to write my question differently. When I write the word log, that's like asking the same question I just asked Jacob. And I'm going to ask the same question. What power of 3 would get me an answer of 9? 2. That logarithm is 2. You ready to go here? Sweet. Let's take a look at just 2 more examples here. 3 more examples. Let's try and take this guy and just rewrite him in logarithmic form. 6. Right. What is my base here? 6. 6. And 6 is going to get me what answer?
36.
36. Very good. I want to get an answer of 36. And that would have to be equal to what power? 2.
I mean 2.
2. Very good. 2. So I've just rewritten 6 squared equals 36 as log 6 of 36 equals 2. Second chart. I want to write this guy in logarithmic form. What is my base?
3.
3. And the base is the number that's going at the bottom. And I'm asking myself, I'm going to take 3, I'm going to raise it to a power and get what product? 27. 27, very good. And that 20 equals, Tony's got it. Last one, Tony?
Alright, I'll do it.
Carson?
Alright. I got it. I do it. Your base is 16.
Careful.
No, stop. Come on.
It got the colors on them.
2, very good. 2. I flip sides on you.
The power, what's that, 16? 4.
I thought you said you didn't want it, Tony.
Right, Tony.
Mike, they got the color
I'm going to leave this
on
up here for a second. I ask that everyone in the room pick up a marker, dishcloth, and whiteboard. I want to actually get started on some practice here.
Okay.
Got it. 10 seconds. 5, 4, 3, 2, 1. Folks, I need your boards up. We are batting 100, folks. We've got... Oh, snaps! Question. I need somebody to volunteer. How do I say that? How do I say that? Sterling, go for it.
Log 3, 1/3. Log 3 of 1/3 equals -1.
Log 3 of 1/3 equals -1. Let me ask a different question. What power do I need to raise 3 to get an answer of 1/3? -1, very good. Real quick, folks, though, I want to, again, let's just take it another step. Let's try and explore what another type of problem might look like. I want to take a look at this guy. What's the one difference between this guy and the previous one?
It's 5x.
Yeah, there's 5x here, right?
There's no base.
It lacks a base. This logarithm lacks a base. This is really the last thing that's worth writing down in your notebook, because oftentimes, especially if you go into medicine, if you go into biology, if you go into astrophysics, if you go into any of those STEM fields, science, technology, electronics, and mathematics, you're going to see logarithms without a base there. So the question is, why isn't there a base? Or what does that mean? What should we see when there's no base here? Because I can't complete this problem without a base, right?
Yeah.
Is it an imaginary one?
Great. Oh,
No.
Tony, you're so... yes. So it's not an imaginary one. But you've got exactly the correct idea. When you have an x here, we generally say that out in front of that x, it's being multiplied by
1.
an imaginary 1. Ladies and gentlemen, if this is blank here, if this is blank, it's not an imaginary 1. It just so happens that it's an imaginary 10.